that all again for the recording. Your test will be up to the end of what we learned this week, or what everyone has learned up to the end of this week. There'll be no measurement because not everyone will get the same amount of measurement in. And even though I will still see you 1 week before the test, I won't see group 2 1 week before the test. So whatever we do in that week cannot be examined. So in 2 weeks' time, I will see you again, but I will not see group 2 again. So at the end of this week is what will be in your test. Yes, Jessica.
Ma'am, how will we organize this, like the test on the same day?
Only the juniors will be at school that day. There'll be no seniors here, so we'll have more venues available. Or there will be matrics, but matrics are in the hall. But there'll be no 10s and 11s. So that's why you write 1 day, you stay at home 1 day. Write 1 day, stay at home 1 day. Because when you are staying at home, the grade 10s and 11s are coming in to write their tests. Okay, yesterday, quick recap, we looked at these weird vertical and horizontal lines that do not follow the y equals mxc formula. Then we went on to actually practice some, and a lot of you did have the confusion of why is it that if it's on my y-axis, it's not called y equals to 0, and if it's on my x-axis, why is it not called x equals to 0? It's always the other way around. Yes, Dominique.
How would we know to use that instead of just a normal one?
Because it's not in the standard of y equals mx plus c. It's either x equals or y equals. There is no other stuff. So when you look at section C of exercise 2.2, you'll see it's y equals x equals. There is no x and y in the same equation. Then we started looking at how to determine the equation. We first wrote down the 2 separate methods where one, the y-intercept is given, and then we substitute in a point, or the y-intercept is not given, we calculate the gradient and substitute in any point. There was our first example that we did. I gave you a graph, I gave you the y-intercept, so we substituted in, we took the point, we substituted in, solved for the gradient, and therefore wrote our final equation down. Then we looked at one where 2 points were given, and even though we can see the intercept, we don't know the number of the intercept. So we have to do the gradient formula, and I was demonstrating how it doesn't matter which coordinate you write first, as long as the up and down are from the same coordinate. And then on the board, I wrote, what happens if we actually swap it? You see that you land up with a gradient that's not what it is. We land up with negative a half, which is not the same as a positive half. Then we wrote down the updated equation. We substituted in any point, can be either one of them, and we found that the equation equals half x plus 4. And that's what we did yesterday. So today we're going to practice doing some more equations and probably start on parallel and perpendicular lines. Okay, today's date is the 25th of May. Not May, August, sorry. I don't even know why I said that. Okay, I'm giving you a third example. Third example we'll do together. And then I'll give you 1 or 2 to do by yourselves. Just want to zoom in a little bit. Okay. So we did try and fix it. That's as close as we could come to fixing the projector. Today is 9OL, group 1, and it is Tuesday.
Yo.
25. Okay, our third example, we are still determining the equation. Gonna give you one. So I'm giving you a graph. And I'm giving you a point. Can we see where the graph cuts the y-axis? So yes, we can see it, and actually we know what that value is. It is cutting at my origin, therefore it is cutting at 0. So it's cutting for 0 for x and 0 for y. But in essence, we have the y-intercept, and so we can update our formula. So even though we started with y equals to mx plus c, my y-intercept is 0. So I'm going to plus 0. What do we do once we've identified our y-intercept? I can see my y-intercept, so I'm doing the y-intercept one. But I could technically do both. I'll show you that now. Yes. I'm going to sub in a point. I've got my y-intercept, substitute in the other point, which is -1 and 4. -1 for x, 4 for y. 4 for y, -1 for x. Is it necessary for me to still write the +0? Is it going to change my sum in any way? So I'm not going to write it anymore. But now I need to get m by itself, which it is. Single, is it single? Is it positive? So I need to still get it single and positive. It is actually single, but it's not positive. Okay? So how do I get m, that is now negative m, to being positive? I'm going to take the -1 over, and technically, mathematically, I'm dividing both sides by -1. So that -1 cancels with -1. M is equal to -4, which I'm going to divide by 1, which is still -4, and therefore y equals to -4x plus 0. But I'm not going to write the +0. So once again, I have a y and an x in that equation, so it is still a diagonal line. If there's no x, then it would be a straight line, and if there's no y, then it would also be a straight line. But they have both, so they are, or it is a diagonal line. So what Jessica asked was, how do we know? How do we know if we have to do the intercept method, or find the intercept first and then sub, or how do I, or maybe I should find my gradient and then sub? You could actually Do either, okay? If you have this kind of situation. If you don't have an intercept, then you are forced to do the second one, okay? But we can do it. So if I had to calculate my gradient, which is y2 minus y1 over x2 minus x1, I need two coordinates. I need that coordinate and I need that coordinate. I have two coordinates. So I'm going to use this one as my first coordinate, 0 for y, 0 for x, minus from the equation. My y is 4, my x is -1. 0 minus 4 is -4. 0 plus 1 is 1. My gradient is -4. Substitute in and get an updated equation. -4x plus c. Take any coordinate you can choose. Let's take 0 and 0. 0 equals -4 times 0 for x plus c. -4 times 0 is just 0. And updating once more. So you would not land up in trouble if you didn't identify it the first time, Jessica. Hannah.
Ma'am, you see where you said, so you start off with your equation and it said equals 0 minus and then brackets 4. Doesn't matter if you say 4 minus 0, because how do you know which?
It does not matter.
So
As long as those two take the whole thing, shift it to the front. So it'll be 4 minus 0, which is +4, and then you'll have -1 minus 0, which is -1. 4 divided by -1 is still -4. So as long as that whole coordinate, top and bottom, shifts to the front, you will get the same answer. So basically, to save your bum, Jessica, you can always do this method. As long as you can see what that coordinate is. Any other questions? Yes, Mark.
Ma'am, can you use that only if you have that?
You do it for any coordinates that you have. So we're going to do another one, or you're going to do one, and then we'll mark it together. So I'll give you a moment to get that down. Okay, we ready for an exercise? Okay, not drawn to scale. Determine the equation. Exercise means you are doing it before I show you how to do it. I'll use my solid from the table as well. Just to clarify, that's -3 and +5. And the number at the bottom is -4. Who's still busy? Give you 1 minute. Okay, let's have a look. So I always start with y equals to mx plus c. Can I fill in the c value immediately? There's my y-axis. It is cutting my y-axis at -4, so I can put y equals -4 in there at the beginning already. What do I need to do next?
I also read the coordinates out of this. I said 0.
That would be your coordinate.
Yeah, that's what I did.
Okay, and then you did your gradient first.
Yeah.
We'll get that in a moment. That's fine. But if I did it this way, where I initially saw my gradient, my y-intercept, what would be my next step? I would substitute in the other point, always. Okay, my other point is minus 3 and 5. Minus 3 for x, 5 for y. Taking minus 4 over becomes, so you can follow this even though you might not have done it this way. Taking my minus 4 over to get m by itself would become positive. 5 plus 4 is 9, equals to minus 3m. M may be by itself, but it is not single and it is not positive. How am I going to make it single and positive? Divide by negative 3, divide by negative 3. Cancelling, m is equal to negative 3. And therefore, my full equation, negative 3x minus 4. Let's look at the way a lot of you seem to have done it, or at least the two in front of me. They decided to make a coordinate, 0 for x, minus 4 for y, and they calculated their gradient, which is y2 minus y1 over x2 minus x1. Does not matter which one I choose first, so I'm going to choose that one first. 5 for y, minus 3 for x, minus 4 for y, minus 0 for x, giving me positive 9 over negative 3, which is negative 3 for my gradient. Therefore, I have negative 3m plus c, and then I can choose either coordinate. I can choose that one, or I can choose that one. I'm going to choose the 0 and negative 4. Negative 4 for y, 0 for x, plus c. Negative 3 times 0 is what? Is 0. So c is equal to negative 4. Therefore, y equals minus 3 for gradient, minus 4 for the intercept. So if you want to just learn one method, then learn that method. Change this to a coordinate and then learn the method. It'll be the same every single time. But once you start getting more confident, you'll realize that this is actually slightly shorter. But if you just want to learn one way and not worry about what to look for, then you do it here. Yes, Shaween? Yes, Mark?
Ma'am, I thought the y equals in x plus c, basically I wrote y first, like I wrote y is first of equals in bracket negative 3. Okay.
Say again, you wrote y equals?
Y equals in bracket negative 3 under bracket, and then I can see off. So that works.
So you jump straight into this.
Yes.
But you already had the negative 4 or you had plus c?
I had plus c and reality.
So you had this. And then your very next step was that. That's fine. But if you don't put it very next step, you're not going to be able to solve for m. Okay. Any other questions? Okay, I definitely think we need to do another one. Okay, another exercise, one for you to practice by yourself. And then we will look at the table method, or looking at a gradient from a table. Okay, exercise, which means it should be done by ourselves first. There you go. Don't just wait for me, please try. Yes.
Will we always be able to do either one of those?
Okay, let's have a look. First things first, let's turn those 2 points into actual coordinates. So what would this coordinate be on my y-axis, Marth? 0 and positive 2. It is my positive. That's just a line showing me where it is. Okay. This one's coordinate, -3 and 0. So let's do it the gradient way. So gradient equals y2 minus y1 over x2 minus x1. Let's take that coordinate. So it is 0 for x, minus 3. 0 for y, minus 3 for x. And here, minus from the formula, 2 for y, 0 for x. I get minus 2 over minus 3, a negative divided by negative. So my gradient is positive 2 over 3. Therefore, I can update and say I have a 2 over 3 gradient, but I still have to plus the c. And then I can substitute either point. Okay, I'm going to substitute -3 and 0. 0 equals to 2 over 3 times -3 plus c. 2 over 3 times -3 is -2. I specifically did it the longer way, and then -2 taken over is +2. Therefore, my gradient equals 2 over 3 is for my gradient. My intercept is +2. I could have substituted the other point in here, and it would have gone a lot quicker. So it would have been 2 for y, 2 over 3 times 0 plus c. That is just 0. So it would just be plus C. Either point, you can substitute, they give you the same answer. Yes, Hannah?
Math, how is 2 over 3 times negative 3 negative 2?
If I do this, I'm just going to write on the side here. The 3's cancel, but my negative does not go anywhere, so 2 times negative 1 gives me negative 2. Okay, I have another one for you to do by yourselves. It's a very quick one, should take less than 30 seconds. It's going to take you longer to draw than it is going to be to answer. Can I shift over the page? Oh, where'd it go? Where'd it go? There we go.
Yeah. Oh, wait.
Dominique and Daniel, there's a new one on the board.
Let me see the reason that there's like arrows missing on the X and Y line.
It's just, we just normally only do it in the positive direction, but not really,
But
no.
now I can do.
Yes, perfect. The higher up in mathematics you go, the more you realize that we do as little as we possibly can. Only giving you 1 minute, starting now. Okay, Arthur, I see your textbook. You can leave it at home, thank you. Dominique, I still need to see your textbook, Caleb and Nathan. You're going to show me a picture of the barcode, you do not have to bring the book. Yes. Pardon? No, it's fine. Okay, so it should be done. I know you still have 20 seconds.
What can do this?
Although I don't think the 20 seconds is going to make a difference.
And I feel like when I find that out, then I'm already stupid.
I'm just going to write the equation. I'm not even going to explain it.
Is it like parallel line? No.
It is not a diagonal line, so there won't be an X and a Y. There'll only be one of the letters. It is cutting the X-axis, so therefore it is X equals whatever that number is. Okay, there's one that I want us to do together because your worksheets does it in these weird, funky ways. So let's look at that. So we'll do this one together. So we are going to determine the equation. They give me a line. They give me the intercept. And then they gave me these two weird things, but not an actual point. But I can infer what that point is. Okay? So if this length here is 1 unit, when I'm going across, am I moving in the x's or am I moving in the y's? In the x. So my coordinate is going to be 1, but is it going to be positive or negative? It has to be negative 1. And then if I started at 3 and I moved up another 3 units, what is that y value going to be? 6. So now I can do That's a point, that's a point. I can do everything I did before. Yes, Mark.
Can I explain it again?
I will. I can see my y-intercept. What is that coordinate of that y-intercept? 0 and 3. Remember, coordinate always has two parts. Since it's a y-intercept, the y has the value, the x is 0. So starting at that point, I get information telling me moving to the left is 1 unit. Moving to the left is moving in my x. Okay? So there's my 1. But I moved in the negative section of x, so it has to be negative 1. Then moving in y, I moved 3 units, but I didn't move from 0, so it can't be 3. I moved from what was already 3, and then I added another 3. And that is what got me to 6 in the y coordinates of the coordinate pair. Moa.
And that, well, you know yourself if you don't think it's right. That's for yourself.
So you always know that the one going across is x and the one going up will always be y, because it follows your axis. There's your x-axis, there's your y-axis. Jessica.
If they give us this in the text, must we show in like writing that?
Depends on how many marks it is, but actually no, you wouldn't have to.
Okay.
So now we can calculate our gradient because we have 2 points. I'm going to do it on the side because my paper's running out. I'm going to take this coordinate, 3 for y, 0 for x, and that coordinate, minus 6 over minus 1, minus 1, giving me minus 3 over minus 3 over positive 1. So my gradient is minus 3. I can determine any coordinate, but I promise you coordinate that has 0 is always quicker. So I'm going to take the coordinate that has 0 in it, 3 for y, 0 for x. C is just equal to 3, therefore negative 3x plus 3. So I want everyone to write that down, and then I want to show you something. Just waiting for Hannah to come back, and then we will look at that. Yes, Mark.
That overall, let's keep that more complicated.
It could get a little bit more complicated, especially when we start considering perpendicular and parallel lines. But as far as what we've done, it's pretty much going to be the same kind of level. So we're just waiting for Hannah to come back. Okay, if she's not back in 30 seconds, we're starting without her. Okay, so we can actually see what this gradient is without the calculation. So this calculation is telling me the growth of my x, how much does it grow, over the growth of, my growth of my y over the growth of my x. Okay, so that is the difference between two y values and the difference between two x values. Okay, this is already showing me the difference between two x values, and this is already showing me the difference between two y values. So I land up getting 3 for the difference in y over 1, which is the difference of x. 3 over 1 is just 3. Okay, that's the number. But then I need to consider that my line is a negative line. So you'll see when you work through the booklet, it talks about that, but I do not like it. I do not like teaching it because learners always mess that up. Okay? This is the safest route to go, and it will be possible in every situation. So if you want to do it that way and go through the booklet next week when you're at home, you are welcome to, but I am mentioning it because the booklet mentions it. So I'll say it again. I'm looking at the change of y values over the change of x values. This is showing me that from that x value to that x value, it is changed by 1, and from that y value to that y value, it's changed by 3. So the y change divided by the x change is 3 over 1, which is positive 3 over 1. So you still need to actually look at the graph and decide, is it a positive graph or is it a negative graph, and then put the negative in front of the number. But again, I don't like doing it because it does lead learners into more trouble than it avoids. Okay, the next one. Now we're going to do the same thing, but instead of giving you a graph, I'm just going to give you a table. And from this table, we are going to follow the same steps. I need to find the gradient. I need to find the intercept. To find the gradient, I calculate y2 minus y1 over x2 minus x1. I choose a point and I sub. The only difference now is that I have lots of points to choose from. That's the only difference. So for your gradient, you'll choose any 2 points next to each other and calculate m. And that gives you m. You're going to update the equation with m. And you're going to choose any point whatsoever to find your intercept. And that's it. Now you might ask, why is it possible to take any 2 points? And I want you to look at this before you continue writing. If I take these 2 points, or I take those 2 points, has my gradient changed? I'm still on the same slope of line. It hasn't gone flatter, it hasn't gone steeper, it hasn't gone from positive to negative. So if I take those 2 or those 2, I can still connect them on a straight line with a ruler. Do you agree with me? If I take that point and that point, I can still connect it in exactly the same straight line with a ruler. Or that point and that point, still the same straight line with the ruler. That is telling me that my gradient is always the same regardless of which points I take. So that is why I say when we do these steps, take any 2 points next to each other, and I only say next to each other so that the sum is a little bit easier. Once you've done that, all these points are on the same line, so it doesn't matter which point you take to find your y-intercept. So we probably won't get to practice that today, but we will definitely practice that on Thursday. Yes, I'll do that right now. Has everyone got access to the group now that I've added the new numbers? So when I see you on Thursday, I'll take this page out again and we will calculate the equation of those values on that table.